All right, chapter 1, lesson 7, scatter plots. I bet you've already noticed this is probably going to be a shorter video, so you're welcome. Okay, only a couple little things today for new things. We're basically just applying yesterday's stuff and then reading the graph. So a scatter plot, a graph that shows the relationship between two sets of data. So in a scatter plot, two sets of data are graphed as ordered pairs on a coordinate system. That's the coordinate system that we learned yesterday. So x and y. So one set of data we put into x, the other set of data we put into y. And that's what makes, and put those in and then see what they look like. Now that could come out three different ways. That's all we're going to get today. We call it a positive relationship. Is if x is increasing, y is increasing. So there's kind of a general that direction. You could also think of if I'm a skier. You know, this would take a cross-country skier. That's a really terrible skier. There we go. To go positive, it would take a positive energy. I just put a lot of energy into going up. So whenever I climb a mountain, I got to put some positive energy into it. Okay, so then a negative relationship would be as x decreases or increases, y now decreases. So we start up high and go down. It's another one you can think of our skier. A negative relationship means he's using gravity to go downhill. So if it's going downhill, it's a negative relationship. Now, if it's just all over the place and there's no pattern, I can't really draw a line any specific direction. We call that no relationship. So that's going to have no obvious pattern. Make sure you write these down. Make sure you know it. This is pretty much all we're doing today. Right, now we're going to take that and apply it into a couple of problems. So the table here shows the average cost of a loaf of bread from 1920 to 2000. You can tell how old our book is. Make a scatter plot of the data. So we start with our coordinate plane. So we're going to let the horizontal axis or the x-axis represent the year. And I just start with the lowest number I have to the highest number I have. And they're in 10-year increments. So I'm going to use each box or tick mark to be 10 years. Or to be 20, 30, 40, 50, 60, 70, 80, 90. Yeah, like that. Okay, so we're going to do kind of the opposite, the other direction. So use the vertical axis or the y-axis to represent the cost. And I just kind of look and say my lowest one's 8, my highest one's 99. So I should probably have between 0 to 90 or 0 to 100 in this case, just to make sure my range is, make sure I got enough space on the graph to make it look good, so we don't have to draw something way up here for some reason. Okay, so then I'm going to start graphing each individual one. Graph the ordered pairs, years to cost. Years goes here, cost goes here. So in 1920, it cost 12. And this is just approximate because it got these weird bubbly things. 1930, it actually went down. 1940 went down again, Great Depression years. After the Great Depression, it bumps up to 15 cents, 20 cents, 24 cents, 52 cents. Big jump between the 70s and 80s. Big jump again up to 1990, and 2000 it cost 99 cents. It'd be interesting to see what it costs today, 20 years later almost, because it's, you know, whatever year it is now when you're watching this video. All right, so the table here shows the number of babies born at Central Hospital during the past 8 months. Make a scatter plot of the data. So I'm going to make a small one here off to the bottom left because I think they're going to put the answer over here. So if I draw this out over here, I have 12 months in the year. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And looks like I have between 10 and 30. So let's just go. Let's draw some lines here. Let's go between, let's do them in fives. So 5, 10, 15, 20, 25, 30, something like that. So January had 12, 21, 17, back down to 9, and then up to 15, 26, we went a little higher, 18, we're around there, and back down to about 11. So it's going to look something like that. That's how I would come up with that. Don't forget to label everything. So down here we would say month. Oh, it's going to let me write it very well. And over here we'd have babies. Yeah, okay, I'm not going to write it very well. So it would look like that. Month, babies, and oh yeah, I probably should have labeled the January through March there, but it was hard for me to write down there. All right, determine whether a scatter plot of data for the following would be positive, negative, or no relationship. So the height of a basketball player and the number of rebounds. Generally, the taller you are, the easier it is to get rebounds. So as the height goes up, the amount of rebounds goes up. So I would say that is a generally positive. So yep, as height increases, the number of rebounds increases. So that would be a positive relationship. By the way, if you don't know what a rebound is, it's when somebody shoots and they miss and somebody else grabs it. So basically, high school basketball in general is all rebounds. I'm just kidding. We do make shots. We work on it very hard. Determine whether a scatter plot for the data or of the data for this relationship is positive, negative, or no relationship. Shoe size and test scores. Okay, so the bigger my shoe size doesn't mean I get a better test score. The smaller my... This looks like there's no relationship because there's no general trend either way. It's just kind of a big block. So as shoes increase, the test scores fluctuate. Yep, that's a nice way to put it. So there's no relationship. All right, determine whether this is positive, negative, or no relation. All right, so the outside temperature and the heating bill. So as the temperature increases, or as the temperature increases, the heating bill will go down. Or you could say as the outside temperature decreases, the heating bill goes up. Either way, so the outside temperature decreases, the heating bill will increase, so that would be a negative relationship. Eye color and test scores. Eye colors and test scores really aren't related, so I would say they're probably going to be a no relationship here. So if I tried to draw that out, the negative one here, if I had made this over here and say outside temperature goes down, then the heating bill will go up. So it just depends on how you draw that. Hey, look, same problem as yesterday. Austin earns $5 an hour doing yard work. Make X represent the number of hours Austin works. So we first make a table of the pairs, and then we're going to graph it. So we make a table, X is 1, he makes $5. We make an ordered pair, 1, 5. 2, 10, 3 hours, $15, 4 hours, 20, 5 hours, $25. No, he does not get paid very much, but hopefully you get paid more than that when you do yard work. All right, so suppose the X represents these hours. Let's now graph these ordered pairs. So we're just looking at these here. So we're 1, 5. Oh, we probably should think about how we're going to do these. So hours we're going to put on the bottom. How much they earn is going to go on the left. And since it's in multiples of 5, we're going to make each tick mark be 5. 5, 10, 15, 20, 25. Now let's describe this graph. Is it going as a positive relationship, negative, or no relation? Looks positive to me. So since they appear to fall in a line, they would be, seriously, describe the graphs. They just literally copy and pasted that from yesterday. Wow, that's hilarious. Your answer should then also say would be a positive relation. All right, I'm not going to make you do this one, but we're going to talk about it. Sue is following the cooking for a recipe of 2 cups of sugar for each batch of cookies. Suppose X represents the number of batches of cookies. So we're going to make a table using X coordinates to be the number of batches and Y to represent the number of sugar needed for each batch. By the way, don't actually try this because adding more sugar when you make the batch bigger doesn't necessarily mean it's going to work because baking recipes and stuff are weird. I've tried it. It's not smart. Anyways, so each one, so 1 would be 2 cups of sugar, 2 batches would be 4, 3 would be 6, 4 would be 8, 5 would be 10. So in this case, yes, it will work. Don't know how it's going to taste, but we'll go with it. So graph the ordered pairs. So I'm going to go 1, 2. Notice on the left here we did 2, 4, 6, 8, 10, 12. You could have done that in 1 through 10 if you really wanted. It wouldn't have mattered. It would just made it more vertical like that. Not a big deal. So 2, 4, 6, 8, 10. And then describe the graph. There will be in a line, and they will have a positive relationship, which I don't know why they're not saying that on here.